Hi, I'm Mike. I go by the artist name Shuttle Option, and I recently uploaded some videos of my Christmas tree doing some cool stuff like playing Bad Apple, running Doom, Rickrolling, and even a fully synchronized light show that I synchronized to one of my original songs. This video is to show you how I did it. Here's the quick answer. I strung my tree and windows with individually addressable LEDs, which basically just means every single LED can be individually controlled separate from all the other LEDs on the strand. And those LEDs are connected to this controller. This controller is connected to my laptop via an Ethernet cable, where I'm running a software called MadMapper. In MadMapper, I can map out the location of all the LEDs on a two-dimensional space, and once I have that map, I can just simply play videos over that map. I can even resize the video so that it better fits the tall shape of my tree, and then that video just gets projected onto my tree. From there, I can just take the Bad Apple music video and press play. Or I can take the Rickroll video and press play. Now, running Doom was a little bit trickier because MadMapper 5 can't capture the windows of other applications, so I had to use a different VJ software for that called LeDMX4. So once I had Doom running on my Mac, which was a little bit trickier than I expected, but totally doable, I used LeDMX4 to capture Doom's application window, the same way that OBS and Zoom can capture the windows of other applications, but Zoom and OBS can't siphon that video feed out to other applications. But in LeDMX4, I can output that feed through Siphon, which is basically just a protocol that allows you to share video feeds from one video application to another. So with LeDMX4 outputting through Siphon, I can now easily go into MadMapper and simply select Siphon as the input for my tree. And voila, Doom is running on my Christmas tree. Or it's at least displaying on my Christmas tree. I guess technically it's running on my laptop, but it depends on where your Doom standards are these days, I guess. But frankly, I don't care, because we just had a hilarious time trying to play this video game on a Christmas tree. It was pretty rough. If you haven't seen it, I'll post a link to the result in the description. Spoiler alert, we didn't get very far. Now, programming a fully synchronized light show with Ableton, I used MadMapper's built-in motion graphics and effects and simply just manipulated them, colored them, programmed movement within them, and saved all of that as different scenes and cues. Then I MIDI mapped all of those scenes and cues to different MIDI notes, which allowed me then to open up my music project in Ableton and add an empty MIDI track that had no instrument or anything on it. It was just there to simply output MIDI to MadMapper. Then I created MIDI clips along that track to play the different MIDI notes to cue the corresponding scenes and cues in MadMapper. So when I play my song back in Ableton with MadMapper open, it will simultaneously trigger all the different light cues at just the right time. Pretty cool. Now, if that piqued your interest and you want to learn how to dive into a custom LED project of your own, stick around because I'm going to get into the weeds of how LEDs work and what you need to know to get started. First thing to note is that there are many ways to go about this. One of which is just to use a consumer-friendly product called Twinkly that'll have everything you need to plug and play into some cool 3D effects right out the gate. Now, you might be restricted to their system and not able to expand beyond its capabilities. I don't know, I've never used it. But if you've used Twinkly, please share your experience in the comments and what limits you've run into and or been able to circumvent getting its technology to work with more custom systems. I'd love to know. But this video is not about Twinkly or products like that. This is for those who want to learn how to build out your own custom LED system that gives you full control over the direction you want to go. I'm going to start off with the basics that's going to apply to any method. And then as we move along, you're going to see some of the decisions that I made, but where you could go in a different direction. And hopefully this will give you a starting point of inspiration to build your own LED project. I'll start off explaining the DMX protocol and the different LED types and the ones that I used. Then the need for power supplies and how to select them. And then I'll finish with the controllers and software that I used. So first up, DMX. Not the artist, the protocol. Now the DMX protocol is made up of channels and universes. There are 512 channels per universe, and each channel is essentially like a fader that can go from 0% up to 100%, but it does it in 256 increments. So technically it goes from a value of 0 up to 255. But we'll circle back on that in a second. The number of universes is really only limited by your software or your hardware. Most likely your hardware, like for instance, your LED controller might only have a certain number of outputs, and each output can only do a certain number of universes. So that would be your bottleneck. But so in a way, you could have, let's say, 4 universes, and each universe has 512 channels within it to work with. So now you have 512 times 4, which is a number I can't think of right now. 2,000 something. 2,048. I'm taking a stab in the dark there. I think 2,048. Don't worry about memorizing all this stuff. It's likely that your software controller will be doing all of this math for you. But it's good to know what's going on in the background in case you run into any issues that you need to problem solve. So how is this applied? So let's take my LEDs that I use on my Christmas tree as an example. So each one of these LEDs has 3 channels to it. One for red, one for green, one for blue. And if we imagine each channel kind of being that fader that can go from 0% to 100%, we can essentially fade the brightness of each one of those colors. And by varying the amount of each color, we can make all the colors of the rainbow. If we have all 3 colors fully bright, now we're getting a white. Now, some LEDs actually have additional channels because it has a separate LED specifically for white. So you would have R, G, B, and W. Even more advanced LEDs will actually have 5 channels. So you can have RGB and then a warm white and a cool white, because technically the white you produce by just bringing red, green, and blue to full might not be like a true white. And so they'll have a true white or warm white LED in there that gives you a more accurate representation of that color that you might be looking for. So those types of LEDs will essentially use up more channels. These, to keep it simple, are RGB LEDs, and they only use up 3 channels. Quick side note, technically these LEDs are actually GRB, so the first channel is green, the second one is red, and the third one is blue. You might not find that out until you plug it in and start messing with the channels and turn them up and seeing what colors you end up with. But once you know, you can program that into your software and it'll sort out the rest. So back to how these channels then are laid out. I need to set the starting channel, this first LED, we'll say the first is channel 1. Well, that means now this LED is actually using up 3 channels. So it's going to use up the first 3 channels of my first universe of 512 channels that I can utilize. So the second LED in line is then actually going to start on channel 4. And then it'll use up 3. And then the next LED after that would then start on channel 7, if I'm doing my math right. So you can see that if I want every LED to do something individual, there can be no channel conflicts. If I start the second LED on channel 2, when channel 2 goes up, it'll actually be turning up the red on the first LED and the green on the next LED. It's doing 2 of those at once. Now, if you wanted the whole strand to all do the same thing, then you could save yourself from using up so many channels and just say every single one of these LEDs is going to start on channel 1. So when I turn up channel 1, all the LEDs for this strand would go green. If I turn up only channel 2, all the LEDs will go red and then blue. But if you want them to be individually addressable and thus controlled individually and all do their own thing, you're going to need to put them all on channels that are not being used by any other LED. If I was using more advanced LEDs that have a warm white and a cool white, say it's using up 5 channels, you could do the math. First LED would be channel 1, second LED would be channel 6, next LED would be channel 10, and so on and so forth. So once you know how many channels each one of your LEDs is going to use, you then multiply that by the number of LEDs that you plan on using. For my project, these LEDs used 3 channels each, and I had 450 LEDs on my Christmas tree. So that meant I was going to be using up 1,350 channels. So that's obviously going to go beyond a single universe of 512 channels. So that's okay. I know that my hardware and my software can handle that. Now, one thing I had to keep in mind about that crossover point is that 512 does not perfectly divide by 3. It comes to about 170 and some change. So that means that after 170 LEDs, the next LED's channel would be channel 511, but it needs to use up 3, so it'd use up channel 512, and then it would have to use up the first channel of the next universe. And the software can handle that no problem. but it's all about how your hardware interprets that. And the hardware, it's common in DMX hardware to not like that, to not want to do that crossover. And so therefore, it's going to expect the software to skip those last couple channels and just start the next LED on the first channel of the next universe. So after the 170th LED, I've only got 2 channels left and I need 3. For my software, I clicked a button, said skip the last channels of a universe, and therefore it just said, okay, I'm going to skip those last 2 because I can't fit a full LED in there, and we're going to make the next LED start on the first channel of the second universe, and then continue the math from there. So in a lot of cases, the software is going to be able to do this math for you, but if you at least understand what's going on in the background, then you might be able to better solve a problem that you might be running into. So this leads us into the types of LEDs you may want to use. So there are all kinds of different LEDs out there. You'll find them on strips. You'll find them even in like grid displays. You'll find them on Christmas style strands like these. You'll find them built for indoor use, meaning they're not waterproof, or for outdoor use, meaning they are fully waterproof, and there's different versions of the waterproofing. The most important decision you're going to be making, though, is the voltage. Keep in mind, you can't mix LEDs of different voltages, and the voltage of your LEDs needs to match the voltage of your power supply and controller. You're going to find LEDs that come in 5 volts, 12 volts, and 24 volts. The higher the voltage you go with, the more LEDs you can have connected in a strand before you have to inject power to maintain the brightness. Because you're going to have what's called voltage drop. The farther down the line you go in LEDs, eventually that power starts to drop off in voltage, and it can't display the brightness that the first LEDs can, which means you then just have to inject power into those LEDs. With 5 volt LEDs, I'm running very safe, super low micro voltage systems. I can accidentally tap the wires and I'm going to get no shock at all whatsoever. When I'm wrapping it around a Christmas tree that's getting drier by the day, I feel a little bit safer about an accident happening and not starting a fire. But if you are an electrical engineer and you're watching this video, I would love to get your input on what are the real risk differences between a 5 volt system, 12 volt, and 24 volt, and how careful should someone be in stepping up between those voltages. Obviously, you want to be careful with any kind of electricity whatsoever at all. For instance, I make every effort to make sure there are no exposed leads, including putting a dab of hot glue at the ends of any power injection leads that I don't crimp my own connector onto. Otherwise, the tips of them are just exposed wires, and the last thing I want is for them to touch something that will spark, heat up, or short the system. But I am curious to know if there is any real major difference in the danger from going to a 5 volt to the 12 volt system or 12 to a 24 volt system, because with the higher voltage, you can go longer without injecting power, means it's less tedious to run wires and so forth. So for instance, with my 5 volt LEDs, I found that I needed to inject power once every 100 LEDs. So these LEDs come in 50 LED strands. So every 2 strands of LEDs, I had to inject power into the wires out here, which I'll show in a little bit. With a 12 volt system, I've heard that you can get upwards of like 700 LEDs before you're going to have to inject power in. That's a lot less additional wiring that you're running. If you're trying to light the outside of your house and you're going these huge distances, perhaps that will add an advantage there as you're running less additional wires to inject power every so often. When I was just lighting up my Christmas tree and the windows behind it, everything's pretty contained to a small area. So all these additional wires I was just running up through the middle of the tree and attaching them to the points where I needed to. It was still pretty contained, a little tedious in making the wires and connectors and putting them all together, but really not that bad once you know what you're doing. And again, now I'm running a very low voltage system in a tree that's really dry and becoming a fire hazard. You're also going to need to take note of the connector that is at the either end of your LED strands. Whatever connector it is, you're going to want to be using that consistently across your system. So these LEDs are using JST connectors. If I'm going to try to attach additional LED strands to them, I'm going to need to make sure they are using the same JST 3-pin connectors. On another LED project, I made my own connectors at the end of these LED strips, and I wanted to make the system super waterproof and very resistant in weather. So I used these way waterproof connectors, and so therefore I'd actually use the same connectors for when I needed to inject power, since I already had my power supply system set up with these way waterproof ones. Then on the additional power injection wires on these LEDs, I just simply stripped them off, attached way waterproof connectors onto there, and then was able to inject power using the same connectors I already had on the rest of my system, while the strands are being connected to each other in a chain via the 3-pin JST connectors that they already come with. If you're pretty savvy on crimping your own connectors, you can always cut the connector off, strip the wires, and attach your own connector on and go from there. If you're getting deep into building out your own LED projects, crimping connectors might become a little bit part of your life, but it's okay because it's pretty easy once you learn how to do them and you get the right crimper to connect them and get them all set up there. You have LEDs that are WS2811s like these. You have WS2812s, 2813s, 2815s. There's a huge list. And essentially by knowing which type of LED you're using, will let you know how many wires it's going to have, how many channels it's running. For instance, these WS2811s, they are 3-wire LEDs. One wire is going to be for the positive electrical signal. The next wire is actually for the data. And then the third wire is for the ground electrical signal. Some LEDs have 4 wires, so they'll have a positive in the ground of the DC electrical circuit, and then they'll have a wire for the data and a wire for the clock. And the clock is essentially providing a more stable communication of the data. This allows for faster refresh rates on LEDs, and it can make it less sensitive to timing interruptions. But not all LEDs have that, some just have the data. I also have done a project with WS2815s. The WS2815 LEDs have 4 wires, but of the 2 data signals, they're actually just identical data signals. One is not the clock. So they took the 2 data wires, you insert them both into the one data output on my controller, and it just becomes a redundancy. So if there's a fault anywhere in one of the data wires, there's a second data wire to keep the signal going so that the system's just a little more reliable. But that's different from having a clock wire. The clock wire provides that more stable communication of the data in regards to timing, and then thus allows the LED to do more advanced things like faster refresh rates and such. Those LEDs might be more expensive, so it all depends on your budget, what you're working with, but you'll still find that 3-wire, 5-volt LEDs are a lot of fun and you can do a lot of really cool stuff with. Just having individually addressable LEDs to work with really allows you to do some really cool creative things. So now that we've selected our LEDs, we need to power our LEDs. Now, a couple of important things to know when selecting a power supply. 1, the power supply's input voltage needs to match the voltage of your wall outlet. 2, the output voltage needs to match the voltage of your LEDs. And 3, the amp or watt rating needs to be equal to or greater than the total demand of your LED setup, plus 25% to allow for power loss and to keep your system from being stressed. So we got to do a little bit of math here. You should be able to find out exactly how much each individual LED is drawing when it's at full brightness. You can find this out from the manufacturer. You might have to hit them up or do a little bit of digging. Should be easy to find. These LEDs from Alitove, they label it right on the strand. So it says electrical DC 5 volt / 0.2 W, 0.2 watts. That means each LED is going to use up 0.2 watts when it is at full brightness. So all 3 of the channels, R, G, and B, are at full brightness. It's going to use up 0.2 watts individually by itself. So for my project, I actually was using 450 LEDs on my Christmas tree, and I used another 450 along the windows behind the Christmas tree. So that was 900 LEDs. So I'm going to take 900, I'm going to multiply that by 0.2 watts of each LED, and that's 180 watts. That's not counting the fact that there's going to be some power loss. So I'm going to want to add even a little bit more wiggle room. So let's just add 25% over 180. And now we're at 225 watts. So my LED system is very unlikely to go full bright white. That was not the intention of the light shows that I want to put on, but maybe there'll be a fault, maybe something happens and everything does go bright white. I don't want that to blow my power systems. I don't want that to cause any issues. So it's always good to work with wiggle room in your system. So I'm going to take the full bright white number and I'm going to add that 25%. And now I've got 225 watts. Now, power supplies are sold in amps. They're sold in volts and amps. So I'm going to need to do a little bit of math to figure this out. DC electrical math is super easy. So we're going to take the 225 watts, we're going to divide that by 5 volts, and that gives us our amp draw. So I've got 45 amps that I need for my power system. So I need a power supply that can do at least 45 amps, if not more. Depends on what increments they're selling the power supplies in. They might sell it in like a 5 volt 20 amp, 5 volt 40 amp. I have power supplies that are 5 volt 60 amps, and I have 3 of those. So I really only needed 1 of my power supplies to supply the power for my entire Christmas LED setup. And yes, if your setup requires more power draw than one power supply's amp or wattage can handle, you can combine multiple power supplies with matching voltages to raise your amp or wattage limit. But you may need to connect a common ground wire between them if your LEDs will all be connected as one system. And this now leads us to controllers and software. So this is where you can go in a totally different direction than when I went, utilizing whatever resources you want to control your LEDs. There's a wealth of different controllers out there, a wealth of different software and coding options to try and make the LEDs do whatever you want to do, and you can go down a path that you feel more comfortable with. I'm going to show you the options that I used, and you can make decisions from there. So I'll show you the 2 controllers that I used for my Christmas tree. Now, these controllers were never running simultaneously. It was either this one connected, or I would unplug it from the tree and connect this to the strands of the tree. That was because I wanted an option that was really easy, just for my wife to come up and push a button, scroll through some different scenes, select a mood or a vibe she wanted to just have in the living room and be done. And then I needed this one though to be able to connect to an external software, which would allow me to do much more complicated things like playing Bad Apple, running Doom, doing a really complex light show via the software. I'll go into this one a little bit more. This is the LeDMX4 Pro. It's pretty awesome for such a small form factor, but just know that this one won't do anything by itself. It needs to be told what to do via an Ethernet cable. There are no buttons or anything on here to control this. So I got this option. Pretty cheap off Amazon. This is the Bandlin X SP601E. I got it off Amazon. There's all kinds of different options like this and similar ones, but I can tell you this one I was really happy with. It can run 5 volt to 24 volts. This one controller can use multiple different LEDs, but it's not going to use different voltage LEDs at the same time because you're only connected to one power supply and it's going to feed that through. You can't have different voltages. So whatever LEDs you have, whether they're 5, 12, or 24 volt, this thing would be able to control them. And it's got Bluetooth built in, so I could use an app to design different scenes using their pre-built options in there. It's kind of limiting if you have a really artistic brain and want to really go far out there, but the options it actually had, I was pretty impressed with. There's a lot of cool options. There's sound reactive options, and it could react to some song you got playing on a speaker nearby or something like that. And it's got 2 outputs, so I had one running the Christmas tree and the other output running all the lights on the windows behind the Christmas tree, which allowed me to create 2 different looks for each output and save them as scenes in the app. And then I or my wife can easily click the M button on the controller to scroll through and select one of those 8 scenes. But that being said, all of the effects are going to be one-dimensional. So it can only do effects that go down, up or down or in from out along one dimension of the LED strand. If I wanted to map the LEDs into a 2-dimensional space and then play effects across them like that, that's when I needed to use software like Mad Mapper, and that meant I needed a controller allowed much finer and detailed control. So this is the LeDMX4 Pro. They actually don't make this anymore. I will link to the updated versions that they have for sale now. I think it's the LeDMX Max series. So I think they're actually better than what this one is, but I haven't used them, but they seem pretty solid, a little more reliable. For instance, this one is only 5 volts. It can only run off of 5 volts, so it can only connect to a 5 volt LED system. But their newer Max series can go 5 to 24 volts depending. But again, that doesn't mean you can mix LED voltages. It just means that whatever your LEDs are and whatever your power supplies are, whether they're 5, 12, or 24 volt, the Max series will be able to do that. This, I know for sure, has a limit of 4 universes per output, and there are 4 outputs, which meant this controller will allow me to run 16 universes of DMX. So let's do the math there really quick. So we're gonna say 16 universes times 512 channels per universe. That is 8,192 channels to work with. I'm gonna divide that by 3 channels per LED. So I could drive 2,730 LEDs, probably like a couple LEDs less than that because there's going to be some leftover channels at the end of each universe. So maybe it's somewhere in the range of like 2,728 or 25 LEDs. Still, a fair amount. It can drive a lot, which is really cool. There's such a small little form factor. That's a pretty big project that you can run off of just this thing alone. These are your 4 outputs, and they use Phoenix connectors, which are basically just pluggable screw connectors, which are pretty common in these more advanced LED controllers. So knowing that my LED strands have 3-pin JST connectors, I simply got a couple pre-made 3-pin JST extension cables, and from the male end of those cables, I cut them the length that I needed, which was only about 6 inches for these 2 outputs. Then I stripped the wires just enough so no leads would be exposed once the wires were inserted. Then I double checked to make sure I knew which wire would be which regarding the positive, data, and ground signals. Then you simply insert the leads into the appropriate terminals, screw them down, and now I have a perfect little adapter to connect my LED strands to the controller. And then this is where the power is inserted into this controller. So I just made my own wire. So the power supplies that I built before use this way waterproof connector. So I just made my own little cable, crimped that connector on one end, stripped the wires on the other, and then you'll just simply, you unscrew these little screws right here. That opens up the little ports. And so then you just shove the wires in there appropriately, positive into the positive side, ground into the negative side, and then you screw these screws and it smashes those wires down into place, and now they're held solidly in there. And then this is the Ethernet port that connects to my computer. DMX over Ethernet is either going to run ArtNet or SACN, something like that. Just basically DMX at its core. It's just allowing many thousands of universes over Ethernet, depending on what your Ethernet's capable of or your bandwidth's capable of, at least hundreds of universes. And this thing can only output 16, so it's going to be plenty, and it's going to be really rocking fast. Now, like many controllers that can output to a ton of universes, they might need a software that tells them what to do. Sometimes that software they come with, and you can program that software and then simply just feed it and read it into the controller and it'll save that. Or if I want to do something complex that it can't, that software can't do, I have the option to use a different software. It's all just going to connect via Ethernet. So I have the option to use whatever software, whatever kind of coding ability that I want, and can just send that down an Ethernet line. So that leads me to the software that I used. I used MadMapper for this project. MadMapper is similar to Resolume, if you're familiar with that. It's essentially a VJ software. VJ meaning video jockeying, so like a DJ, but with video. So when you go to a concert and you're seeing the screens on stage doing crazy cool graphics and fading things in and out and just doing really wild stuff visually, that's being run by either Resolume, MadMapper, Touch Designer. There's a number of different softwares out there that'll do that at that professional level. It might also be the stuff when you see someone's projecting onto a building and they're making it look like the windows are open and closing or on fire, and then there's a whole show going on projected onto the building, but all the elements of the building are all individual parts of the show, but it's just like a couple of projectors and that's it. They're using a software like MadMapper or Resolume or something where they have mapped the projectors to display certain things in certain places and make it look like the building is alive and reacting. MadMapper has a great setup for building out LED fixtures. I found some limits on this particular project when I wanted to map out the tree itself, but I liked it better than Resolume. At least 6 years ago when I first was diving into this, Resolume wasn't great at building out light fixtures that would use more than one universe. And so when you're doing LED projects that have thousands of LEDs in there, you're easily using up multiple universes. And I want to be able to just say that like that's all one fixture, that's all one light fixture as a group moving around. MadMapper did that really well. Being able to just take this fixture and multiply it across and then group it all together, and it's just one thing, and then I can manipulate this one fixture even though it's multiple universes of LEDs. So I've tried to cover as much as I can in this video to show you my process and help you understand what you need to know to embark on your own LED journey. But if I've missed anything, or if you have any other questions, or if you actually know of other controllers or software or tips and tricks of your own with LEDs, please feel free to share it all in the comments. I'd love to have a healthy discussion there that other people can learn and get inspired from. Otherwise, get out there and get lit. Wordplay!